In this video, we're going to talk about partial fractions. Now, in this first example, we're just going to try to find the form of the partial fraction decomposition without actually working it out all the way and finding the coefficients a, b, c, and so forth. So in this one, notice that in the denominator, it's already in factored form, so that's good. The first factor here is x plus 3, and it's not repeated at all. And so in our partial fraction decomposition, we're going to put a over x plus 3. The second factor is also a linear factor. It's of the form mx plus b, just like the first one was. So we can put b over 6x minus 7. Now the next factor is x plus 5. In fact, we have x plus 5 occurring 3 times. It's really x plus 5 times x plus 5 times x plus 5. Now it would be a mistake to put c over x plus 5 plus d over x plus 5 plus e over x plus 5. Okay, this would be incorrect. In fact, when you have a repeated factor, what you need to do is first of all put the c over x plus 5, but then you put d over x plus 5 squared and then e over x plus 5 cubed. Okay, and then we still have this last factor. Now it's repeated. X squared plus 9 is repeated because it's x squared plus 9 squared, but x squared plus 9 itself is not a linear factor. It's an irreducible quadratic. We can't factor x squared plus 9 unless we use imaginary numbers. So how do we deal with a quadratic factor, irreducible quadratic factor? Well, instead of putting just f over x squared plus 9, I'm going to put fx plus h. Okay, you put a linear factor on the top. Now, since it's repeated, we're going to put x squared plus 9 squared on the next one. And let's see, a, b, c, d, e, f. Oh, I guess I should have put g. This would be hx plus I. Okay, a, b, c, d, e, f, g, h, I. Okay. All right, so that is the form of the partial fraction decomposition. Now, to actually find these numbers, a, b, c, d, e, f, g, h, I, it would take some work, but this is the form of the partial fraction decomposition. Now, why did we deal with repeated factors the way we did, and why did we deal with these irreducible quadratic factors the way we did? Well, let's take a look at an example. Find the partial fraction decomposition of 6x squared plus 3x plus 2 over x times x squared plus 1. Now let's begin with the incorrect method. Okay, let's go incorrect method. And let's suppose that we thought we could put this as a over x, okay, which that's okay. That's by the way, x is just kind of like x plus 0, so that's a linear factor. Plus, let's suppose we thought we could just do b over x squared plus 1. Now we know it's supposed to be bx plus c, but why wouldn't b work? Okay, well, if we multiply both sides, okay, multiply both sides of this equation by x times x squared plus 1, what do we get? Well, the left-hand side would simplify to be 6x squared plus 3x plus 2. The right-hand side, well, we'd multiply this first term by this factor. The x's would cancel, and we end up with a times x squared plus 1. We multiply this by the second factor. The x squared plus 1 would cancel, and we'd end up with bx. Okay, now notice what's going to happen here. Well, if I write this out, this right-hand side would be ax squared plus a plus bx. Okay, and this is equal to 6x squared plus 3x plus 2. So now notice the a here, the coefficient of the x squared should be the same as the coefficient of the x squared here. So in other words, a should equal 6. Okay, but also there's a little bit of a problem though. The bx, the b should be 3 because right here, right, this b should be 3. But notice what should the constant be? This constant should be 2. And so notice what we get is that a is 2, but there's a problem. Okay, we have a problem right here and right here. A can't be both 6 and 2. Okay, so there actually isn't any a and b that would make the left-hand side up here equal to the right-hand side. And so what was the problem? The problem was that we just put b over x squared plus 1. Okay, we did not put bx plus c. So this was the incorrect method. Okay, so now let's do the correct method. Okay, let's go down and write it as, let's see, we had x times x squared plus 1 We had 6x squared plus, what was it, 3x plus 2. Okay, so now let's do this the correct way. Let's see if we can get it to work out. Okay, well, we write this as a over x plus bx plus c over x squared plus 1. Okay, and now notice, again, we multiply both sides by x times x squared plus 1. And notice the left-hand side, again, would simplify to be this. The right-hand side, we'd have a times x squared plus 1. Because when we multiply this factor here by a over x, the x's cancel, and we're just left with x squared plus 1 and the a. And then when we multiply this factor by x times x squared plus 1, the x squareds plus 1's cancel, so we're left with bx plus c times x. Okay, now if we write out this side here, we get ax squared plus a plus, well, this would be bx squared plus cx. Okay, so let's combine our like terms here. We have an ax squared and a bx squared. That's really a plus b x squared plus cx plus a. Okay, now the a, this right here, should correspond with the constant over here. Okay, so a is equal to 2. And then the c, this c, should be 3, right? C should equal 3. And last of all, what we have is that 6 is equal to a plus b, right? A plus b is equal to 6. So what is b going to be? Well, a was 2, so b will be 4. Okay, so we found our a, our b, and our c. So in fact, what we can say is that this original expression was equal to a over x, but that would be 2 over x, plus bx plus c, that would be 4x plus 3, because b was 4 and c was 3, over x squared plus 1. And it turns out this is the partial fraction decomposition of this. Okay, we began with a rational expression, a rational function, and we broke it up into its partial fractions.